Hello dear students, let us take a problem under bolted connection. Determine the number of bolts required to connect two angles ISA 75 by 75 by 6 mm to 12 mm gusset plate of M20 grade 4.6 property. Bolts are used to connect system in the following figure. Take Fi 250 MPa and Fu 410 MPa. So here this is a cord. The cord is connected to the gusset plate. Further, we are going to connect two ISA equal angles. See here one angle we have, back side also we have one angle. Here also one angle, back side that one angle. Actually this will come at the top. Behind that we have the gusset plate. Behind that we have another angle. Okay, so this is called gusset plate. This is called gusset plate that is having 12 mm thickness. So the forces acting on the cord are also shown, 375 kilonewton and 250 kilonewton. These forces acting on the ISA angles are 125 kilonewtons each. So this problem was asked in the previous question paper. So for 10 marks they have asked, I think. Now let us list out the given values. The given values are thickness of the gusset plate 12 mm, angles ISA 75 by 75 by 6 mm, diameter of the bolt is given 20 mm, here they have given M20. Okay, then D naught equal to 20 plus standard clearance to 22 mm, Fy Fu, then bolts of 4.6 class they have given, that means FUB equal to 400 Newton per millimeter square. Then let us assume only threads in double shear plane. So that means A and B is taken as 0.8 times pi by 4 into 20 square by assuming ISO threads, which works out to be 251.32 millimeters square. Now let us calculate strength of the bolt in shear, that is VDSB. So VDSB equal to VNSB by gamma MB. So that is, it is a two-way shear or double shear actually. So 2 into FUB divided by root 3 into gamma MB NN A and B plus the NS ASB tend to 0. So upon substituting we get 92.864 kilonewton. Now the strength of bolt in bearing works out to be VDPB equal to 2.5 kb dt Fu divided by gamma MB. Let us calculate edge distance and pitch. Edge distance we are going to take it as 1.7 times d naught, that is 1.7 into 22, 37.4 taken as 40 mm. Then the pitch distance is taken as 2.5 times the diameter of bolt, works out to be 50 mm. Let us take it as 60 mm. So kb is the smallest of four values, E by 3 d naught, P by 3 d naught minus 0.25, Fu by Fu and 1. So out of all these four, E by 3 d naught gives least value 0.606. So we are going to take kb equal to 0.606. Now you see the continuation of this. We are going to calculate VDPB. So VDPB works out to be 119.261. So out of the design shear strength and also the design bearing strength, the least value will give you the bolt value. So least of VDSB and VDPB equal to 92.864 kilonewton, that is the shear. So 92.864 is the bolt value. So now let us calculate number of bolts required. The given load is 125 kilonewton acting at the equal angles. The factored load is to be considered always for the design. So factored load is 1.5 into 125, 187.5 kilonewton. So number of bolts required to connect two ISA 75 by 75 by 6 mm to the gusset plate is equal to factored load divided by bolt value, that is 187.5 by 92.864, works out to be two numbers. Now again I have to do one more connection, that is a cord member to be connected to the gusset plate. So for that, a cord member is assumed to be a continuous one. So these two are the loads, or the resultant load is nothing but 375 kilonewton minus 250 kilonewton works out to be 125 kilonewton. Otherwise, you can resolve these two into two components, horizontal and vertical, and you can find out the resultant. That also works out to be 125. Calculate the factored load now, 187.5. Therefore, number of bolts required will be 2.01. So we call it as totally 3 numbers for cord members. So the load is comparatively more, so we will go with the higher number, 3 numbers. So this is how the bolts are placed. So for these ISA equal angles, totally 2 plus 2, 4 numbers of bolts are placed here, and for cord totally 3 number of bolts are placed. This is how the connection looks in the detailing. Hope this problem is clear. Now in few of the problems, the HSFG bolts, high strength friction grip bolts, are also may be asked. So till now whatever the problems we have seen are under the black bolts. Now the high strength bolts we will see how to do the design. So here only the change is in the design of shear resistance, we have to use some other formula. The design frictional force produced, which is given by VDSF equal to VNSF by gamma MF. So VNSF is mu F into Ne into Kh into F naught divided by gamma MF. So here VNF is nothing but nominal frictional capacity produced by a bolt. Mu F is nothing but coefficient of friction, which is also called as slip factor, usually taken as 0.55. Then Ne is the number of effective interfaces offering frictional resistance. Kh is equal to 1, that is for the standard clearance. Kh is also a factor. Then gamma MF is 1.1 for service load and 1.25 for ultimate load. Then F naught is nothing but the proof load, which is A and B into F naught. We know how to calculate A and B. Now F naught is the proof stress, 0.7 times FUB. So remaining steps will remain the same, only change in the first step. So this is how you can calculate the shear resistance of HSFG bolt. That is also called the design frictional force produced, VDSF. Now we will take a problem related to this. Find the maximum force which can be transmitted through the lap joint connection of two plates of 8 mm and 10 mm thick with 8 mm bolts at a pitch of with 8 bolts at a pitch of 60 mm, gauge distance of 50 mm and edge distance of 35 mm. Also find the efficiency of joint using bolts of property class 8.8. So here nowhere they have mentioned it is HSFG bolt, but there is a clue or there is a hint which says that the bolts are HSFG, that is class 8.8. Class 8.8 is always high strength frictional grip bolts. So this is how the connection look like. Here in the two columns we can find the bolts. So totally 1, 2, 3, 4, 5, 6, 6 number of bolts are there, 2 columns and 3 rows. So given values, the thickness of plate equal to 8 mm. So one plate is 10 mm, another plate is 8 mm. Out of this the least value is 8. So least value is to be taken as the thickness. So T is equal to 8 mm. Then diameter of the bolt by using Unwin's formula, D equal to 6.04 into root T works out to be 17.08. So let us, usually Unwin's formula gives higher value. So a smaller value than that, D equal to 16 mm let us take. Therefore D naught equal to diameter of the hole, that is equal to diameter of the bolt plus standard clearance. Standard clearance is 2, therefore it comes to be 18. Then pitch is 60, gauge is 50, then edge is 35 mm, FU 410, FUB 800 MPa, and B is the width of the plate. 50 plus 50 plus 35 plus 35 works out to be 170 mm. Now let us calculate the strength of bolt in shear using clause 10.4, page number 76. The previous formula we have noted that VDSF equal to VNSF divided by gamma MF, that is mu F into Ne into Kh into F naught divided by gamma MF. So that is equal to, the mu F value is equal to 0.55, Ne is 1, Kh is 1 and F naught equal to 0.7 times FUB, that is used to calculate F naught, capital F naught, that is equal to A and B into F naught. So the value of F naught works out to be 87.824 kilonewton. Therefore when I substitute this value of F naught in VDSF equation, I get VDSF equal to 43.912 kilonewton per bolt. Therefore, for 6 number of bolt, VDSP works out to be 6 into 43.912, that is 263.472 kilonewton. So finally, strength of bolt in bearing given by VDPB equal to 2.5 kb d TFU divided by gamma mb, same formula. The kb is the least of 4 values. Out of this, the least value is E divided by 3D naught, works out to be 0.65. When I substitute kb in the above equation, I get VDPB equal to 68.224 kilonewton per bolt. Therefore, for 6 bolt, the VDPB works out to be 409.344 kilonewton. Therefore, strength of the plate in tearing or tension capacity of the plate is given by TDN equal to 0.9 B minus N into D naught into T into Fu, where B minus N D naught into T is nothing but AN. So, AN is calculated using this particular formula, B minus N D naught into T. So, upon substitution, we get 273.946 kilonewton. Here you may get a doubt why N equal to 3, because we have totally 3 number of bolts where the section considered for tearing, or simply we can say there are 3 rows, so 3 will be the value of N. So maximum force which can be transmitted through the given lap joint is the least of about 3 values. Least of above 3 values is equal to, due to the shear, 263.472 kilonewton. Therefore, to calculate the efficiency, let us calculate strength of solid plate. Strength of solid plate is given by 0.9 into Ag into Fu divided by gamma m1. So, works out to be 401.472 kilonewton. Therefore, the efficiency is given by strength of joint by strength of solid plate into 100. Therefore, efficiency eta equal to, upon substitution of values, we get 65.63%. We will try to take one more problem under HSFG bolt in the next video lecture, and we will take few more problems also which were appeared in the previous year question papers in the coming lectures. Thank you.